Hi everyone, welcome to the end of activity 11.3, which is also the end of our polynomials, and we're going to start talking about polynomial inequalities. And this is starting on page 149 in your books. Now we're going to skip through this top portion, but I want you to look at the middle of the page where it starts talking about solving and our steps to solving polynomial inequalities. And basically what we need to do is we need to write the inequality in factored form, identify the zeros, and then pick a testing value that falls in between those zeros each time, evaluate the polynomial at these values so we can test if the sign is positive or negative, and then eventually answer the question by stating our solution intervals. So how this is going to look, there's an example here. First thing you need to do is set this, in a sense, equal to, but move everything to one side of the inequality symbol, so that you are able to factor this, just like we did with activity 10, when we're looking to factor and find all of our zeros. So in this case, there are 3 zeros, 0, 1, and -3. So the next piece then, after we have these two steps, step 1 and step 2, is we need to test the intervals. So we want to think about on the number line, we have our 3 values at -3, 0, and 1, and we need to decide, is our graph going to be above the x-axis over that interval or below the x-axis over that interval? So you're going to pick numbers that fall on those intervals to test that. So for instance, they tested -4 to test this first interval. And -4 ended up multiplying to be a negative number. We don't really care what the value is, we just know it's negative. And then we tested -1, which fell in interval number 2. That actually ended up being a positive number. And you'll see these tested patterns continued on the next page. So this is what they did. They found this negative, positive, negative, positive on these intervals using the points they tested with. So what that means is for our graph, we know we are going to be above the x-axis from here to here and from here to here. So again, greater than or equal to 0 from the values of -3 to 0 and 1 to infinity. So that would be our answer, and we would write that using our interval notation here, those two intervals. Reminder, if you are including the 0, it's going to be a closed circle and a bracket, versus when it's just greater than, we're not going to include it, would be an open circle and a parenthesis. Infinity signs are always parentheses, and so is negative infinity. Now again, you can always check on your graph if that interval solution was correct by looking at the graph, and again, where is it greater than or equal to 0? Okay, so basically what we're looking for when we're looking to find the polynomial inequalities, for any solutions greater than or equal to 0, it's where the x-intercepts, the graph is above the x-intercepts, versus when it's less than or equal to 0, graphs are below. Or your x-axis, but x-intercepts are the same there. Okay. Now, looking at the examples that they have here, we have 4 examples. I'm not going to lie to you; they do not give you a ton of space to write, so you may want to jot these down in the My Notes section, or possibly even in another notebook, because they do not give you very much room to write it all. Okay, so here on this particular problem, they started by moving everything to one side for us, which is really nice. So when we factor, we just have to figure out what multiplies to be -2 adds to be -1. Well, that's going to be -2 and 1. And that means that our 2 zeros are at 2 and -1. So what we're going to do is we're going to plot on a number line, -1 and 2. So these zeros, again, are not going to be included in our final solution. So we're going to want to leave them open circles because we're not going to want to include them. And now we have 3 different intervals we want to test to see would the answers be positive or negative. So I'm going to start by choosing a number less than -1. So I like to just choose, a number like -1 million, because officially that's less than -1. And if I plugged -1 million in here, it would be a negative value. And if I plugged -1 million in here, that would also be a negative value. Well, a negative times a negative ends up being a positive number. Okay. Now I need to test interval number 2. And with interval number 2, I'm going to pick a number between -1 and 2. So 0. If I plug 0 in for x, I get -2 times +1, which is an overall negative number. So I get a negative number. Again, I don't really even care what the number is. I just need to know, is it going to be above the x-axis or below the x-axis? Last but not least, I'm going to choose a number bigger than 2. I'm going to choose 100. That's bigger than 2. 100 minus 2 is a positive number. 100 plus 1 is a positive number. A positive times a positive is a positive answer, which means my answer would be above the x-axis here. So if we look at here at the value here, we're looking for where is our graph less than 0, aka where is our graph going to be negative. This is the region we would shade. So in between -1 and 2 on our graph is where this is going to be below 0. So our final answer would be between -1 and 2. Now again, you can confirm this answer by looking at the graph. If we graph this in the calculator and look, what we're going to see is that our graph is below -1 or below 0 from -1 to 2. And so we can confirm that that's the interval. All right, let's try another one. So on this particular problem, they again leave everything on one side for us, which is good news. So all we have to do is factor. So we end up with x squared minus 9, x squared plus 9. And if we factor this a little bit further, we can factor this x squared minus 9 to be x plus 3 and x minus 3. And officially, the x squared minus 9 is going to give us imaginary answers when we try to set these equal to 0. So I'm not saying that they're not important, but when it comes to actually looking at a graph, the imaginary zeros aren't going to show on our graph. So what we need to make sure we do is we need to kind of ignore those for the sake of this problem. Even though they are zeros, they're the imaginary ones. And we're only going to focus on the real zeros of 3 and -3. So again, we're going to plot these on our number line, and this time we want to include them because it's or equals to 0. We want to include them. We'll fill in the circle. And now we want to look, okay, where is this graph above the x-axis? So I'm going to pick a number less than -3. So let's say -100. If I plug in -100 here, I end up with a negative answer times a negative answer times a positive answer, because I'm still going to plug into this piece here. And so a negative times a negative times a positive is an overall positive answer. And if I plug in a number between -3 and 3, like 0, I get a negative times a positive for an overall negative answer. And then last but not least, a really big positive answer here, so positive number like 100, positive times a positive is positive. Okay, so on this particular problem, our graph is above 0, so greater than 0 over 2 intervals, here to here and here to here. So from -infinity until we get to -3, and we include it because we had the filled in circle, or from +3 to infinity. Now, you do not want to always assume, you might be getting into this pattern that it's always just going to flip-flop to be positive to negative to positive. That is not necessarily the case, because we want to make sure that because you never know if there's a multiplicity involved or something like that where you might get the bounce back. So don't just get in the habit of assuming that these are always positive, negative, positive, because that's not always the case. All right. One last answer, or one last problem I would like to do together is going to be, let's look at part D. So part D here, we want to start by rearranging everything so that it is on one side of the inequality. So I'm going to subtract the 3x squared and the 32x back to the left-hand side so that I can keep my x cubed positive. And now I can look at this and say, okay, I think this looks like a factoring by grouping situation. So I'm going to take out an x squared here, So we're left with 2x minus 3. And then in the second piece, both of these have a 16 involved, in fact, negative 16. So we could say 2x minus 3, because we're taking out a negative 16. And then again, from here, we have two factors, x squared minus 16 and that 2x minus 3, which means our zeros are going to be at, well, if we keep factoring a little bit more, we're actually going to see we have x minus 4, x plus 4, and then that 2x minus 3, which leaves our zeros to be at 4, negative 4, and 3/2. Okay, so I'm going to plot these on the number line. We have negative 4, 3/2 is 1.5, and positive 4. And this time we are including these zeros, so they're going to get filled in. Now, when we test these values, again, I want to plug in a value much more negative than negative 4. I mean, it could be negative 5, but I like to do like really big negative numbers. So let's say negative 100. So that would be a negative value, and then still a negative value. So 3 negative values multiplied together create an overall negative value. A number between negative 4 and 3/2, like 0, would be a negative times a positive times a negative. And negative times positive times negative is an overall positive answer. A value between 1.5 and 4, like 3, would lead us to have a negative answer, a positive answer, and then another positive answer. So a negative times 2 positive is negative. And then last but not least, that really positive value, let's say 100, positive, positive, positive. Our overall answer is positive. So again, I don't want you to get into the habit that this is always going to flip-flop, but in this case it did. So again, we're looking for the values less than or equal to 0. So that's going to be our negative answers, our answers below the x-axis. So that means from negative 4, from negative infinity, until we get to negative 4, we're including it though, because we want to keep 4 equal to 0, or from 3/2 to 4, include both of those, would be our intervals. So again, be careful. What makes C and D a little bit more challenging is you need to make sure that you move everything to one side before you get started finding your zeros. Last but not least, our couple extra questions here was 6 and 7, 8 and 9. A couple of things here. When we have looking for these sign patterns, polynomial inequality, is there a way to tell the maximum number of intervals that we're going to create? Well, the number of zeros plus 1 is going to equal the number of intervals that you're going to want to test. Okay, so notice if we had 3 zeros, there were 4 intervals we needed to test. If there were 2 zeros, there were 3 intervals we needed to test. So we always have one more interval to test than the number of zeros you have. And then again, when you're testing out these intervals, again, it's always going to be those pieces between your zeros on these. And let's see. A reminder that interval notation is the same idea as inequality notation. When we talk about inequality notation, for example, with number 8, if we're talking about from negative 4 to 0, if we were to rewrite this using inequalities, it would look like this. Now notice these are parentheses, so it's just less than, not or equals to signs. And then when we talk about 2 to infinity, that means that we would want all the x values greater than 2 if we're talking about going to infinity. Okay, that union symbol in between there just means or. We are going to usually use interval notation like they have in number 8, but again, officially, inequality and interval notation do the same thing. Okay. And then last but not least, a reminder, you guys have the advantage of being at home with your graphing calculators. You're still going to need to show the work for these problems, but officially, when you are looking at these you can always graph them and double check, because if you're looking for where is this less than or equal to 0, you always want to just look at your graph and say, all right, where is the graph below or touching the x-axis. Okay, so you can always look at these graphically as well to double check your intervals, but you will be required to show work on certain problems, so know the process as well. We will work more with this in class tomorrow, and have a great rest of your day.